Dear students, in this session we will discuss about theorems on circles. Here, the basic definition of circles. Circle is a collection of all the points in a plane with a fixed distance from a fixed point. Let me suppose take a point here with equal distance if we draw, and each of these points, if we join together, we will get circle. So, circle is a collection of all the points which are equal distance from the fixed point. So that this is the circle in a plane. Suppose if we take a piece of paper and if we draw, so this is a circle. Circle is a two-dimensional figure. The fixed point is the center of the circle, and this fixed point with the fixed distance, this distance, equal distance is called the radius of the circle. If we take two radius together, it will become diameter of the circle. If we take a plane and if we draw a circle, the circle divides this plane into three parts. Interior of the circle, the points on the circle, and the exterior of the circle. Here, the point P is the interior of the circle, is in the interior of the circle. The point Q is on the circle. The point R is outside of the, it is exterior of the circle. Next, circular region. So, the region is the circle and its interior. The circle and its interior. That means the points inside the circle and the points on the circle together is called the circular region. Circular region means the collection of points inside the circle as well as the points on the circle is called the circular region. Circle means only the collection of points on the circle. Collection of points on the circle is called circle. Circular region means the points, the collection of points inside the circle as well as the points on the circle. The line segment joining two points on the circle is called a chord. If we join any two points on the circle, this is called chord. So, we can draw infinite number of chords. If the chord is passing through the center, that is the largest chord, that is called the diameter of the chord. So, diameter of the circle is diameter of the circle. So, diameter of the circle is the largest chord. So, the chord diameter, we can draw even infinite number of diameter also. We can draw infinite number of diameters. A piece of circle between two points is called arc. If we take a circle from one point to the other point on the circle, if we take, this is called the arc of the circle. This is an arc, and as well as this is the another part of the arc. So, the circle is divided into two arcs. So, here this arc is called the minor arc. The length of the small arc is called the, if the arc is smaller, it is called the minor arc, and if the length of the arc is large, it is called the major arc. So, it is divided into two segments. One is the minor arc and another one is the major arc. Next, we will see about the circumference. The length of the complete circle is called the circumference. The length of the complete circle is called the circumference. If we take circle, the total length of the boundary is called the circumference. The region between the chord and the area of its arc. So, if we take an arc, if we take a chord, the region between this chord and this segment and this area is called the segment. Okay, so this is the segment of the circle. So, this is one segment. This is one segment. That means the region in between the chord and the corresponding arc is called a segment. And the other segment is this one. So, this is the segment. That means the region in between the chord, and the corresponding arc. If the region is in between the chord and the minor arc, it is called a minor segment. If the chord is in between, if the region in between the chord and its minor arc, the smaller arc, this region is called minor segment. The region in between the chord and the major arc, the region in between the chord and the major arc, this region is called major segment. Next we will come to the sector. Sector is the region in between two radius and the corresponding arc. Two radius and the corresponding arc. This region is called the sector. Here, the region in between two radius and the minor arc is called minor sector, and the region in between two arcs and the major arc. The region in between two radius and the major arc is called major sector. In between minor arc and the two radius is called minor sector. So it is about major sector and the minor sector. Next, circular disc. Circular disc is the collection of all points lying inside and on the circle. Collection of points lying inside and on the circle is called circular disc. So the points lying inside as well as on the circle is called circular disc. The circular disc means the collection of points inside as well as the collection of points on the circle is called circular disc. So this is only circle. This is called circular disc. So circular disc means the collection of points inside as well as the points on the circle. So this circular disc can be denoted by C of O, R. Here O is the origin, the center and the radius. Circular disc with the center O and the radius R. This can be written in the set form as C of O, R equal to set of all points X. Set of the collection of points X such that what is the condition for X? OX should be less than or equal to R. So if we take the center O and the radius R, so this X can be, the length of X can be here, that means the length of OX, the point X is here, length of OX is less than R, or otherwise if the point is on the circle, X, if it is on the circle, so that we can say OX equal to R. So OX is either less than R or equal to R. So length of OX is less than or equal to R. Collection of points X such that length of OX, distance from O to X, is less than or equal to R. So the collection of all the points inside, so from the center to the point, so this is OX. So all these OX are less than R. If you take the points on the circle, all these OX are equal to the radius. So less than the radius or equal to the radius, all these collection of points together is called circular disc. If there are more circles with a common center, we take a circle. So the collection of more circles with a common center is called circular disc. So all the circles with the same radius, same center, common center is called circular, is called concentric circles. Next will come to central angle. Let the circle C of O, R be any circle whose vertex is at O. Then the central angle is POQ. The angle POQ is the central angle of the circle C of O, R. So, this angle POQ is for the minor arc PQ, and for the major arc if you take any point R here. So, angle P, reflex angle POQ is the angle at the arc PRQ. Angle at the arc PRQ is reflex angle POQ, and angle at POQ is at the arc PQ. So, we can write this reflex angle POQ as this we can rewrite as QP also, from Q to P. This length is called the major arc. So, the measure of the angle at the center is called degree measure of the arc. So, that it is represented as theta. It can be represented as theta. So, measure of PQ and measure of QP together, it is 360 degree. So, if this is theta, the remaining angle will be 360 minus theta. So, measure of the circle C of O, R is 360 degree. The whole set of angle is, sum of the whole angle is 360 degree. So, that is the degree measure of the arc. Angle POQ is a central angle for the circle C of O, R. Degree measure of the arc. What is the degree measure of the arc? For the minor arc PQ, the corresponding angle is theta degree, and for the major arc PQ, the corresponding angle is 360 minus theta degree. So, theta degree plus 360 minus theta degree is the whole complete angle of the circle C of O, R. Next, congruent circles. If two circles are congruent, if we superpose one circle, if we cut one circle and superpose one over the other, it covers exactly, so that we can say two circles are congruent. If two circles are congruent, if they have same radius, if the radius of the first circle equal to radius of the second circle, then we can say these two circles are congruent. So, the main concept is, if we cut one circle and keep over the other, it will match exactly, so that we can say these circles are congruent. If two circles are congruent, the condition is the radius of the first circle equal to radius of the second circle. Radius of the first circle equal to radius of the second circle, so that we can say two circles are congruent. Congruent arcs. If two arcs are congruent, if one of them can be superposed over the other, it will cover exactly. If you take one arc of the circle, and if you take the other arc of the same circle, and if you cut and keep one over the other, it will cover exactly. Otherwise, if you take two circles, one arc here and another arc in the other circle, and this arc if we cut and keep over this, if it match exactly, then we can say these two arcs are congruent. This congruency we can prove either in the same circle or in two different circles also. Two arcs of a circle are congruent if they have same degree measure. So, if two arcs are congruent, so that the angle subtend at the center are equal. If two arcs are congruent, the corresponding angle, degree measure of the angle is, degree measure of the arc is same. So, if the arc, suppose if we take this as PQ and this is RS. So that PQ, the arc PQ equal to is congruent to arc RS. Then degree measure of the arc PQ equal to degree measure of the arc RS. So that angle POQ equal to angle ROS. So both of the arcs are congruent. The angles subtend at the center are equal for the corresponding arcs. Theorem 1. Equal chords of a circle subtend equal angles at the center. So what is given here? Two chords are equal. That means the chord AB equal to chord CD. So we need to prove that the angle at the center are equal. So chord AB equal to chord CD. We need to prove is angle AOB equal to angle COD. So let us move for the proof. So here, this OA, OD, OB, OC are the radius. So definitely all those radius are equal. OA equal to OD, OB equal to OC because the radii are equal. All of the radii are equal. And it is given that AB equal to CD. So, OA equal to OD. This AB equal to CD is given. And OB equal to OC. So, all three sides are equal. So, by SSS congruency, criteria, triangle AOB is congruent to triangle COD, which implies that the corresponding parts of congruent triangles are equal. So by CP/CT, corresponding parts of congruent triangles, two triangles are congruent we proved. So the corresponding parts, angle AOB equal to angle COD. That means angles subtend at the center are equal. So equal chords of a circle subtend equal angles at the center. So chords are equal is given. We need to prove that they subtend equal angles at the center. That has been proved. Next one. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Here, the angle at the center are equal is given. That is, what is given is angle AOB equal to angle CO'D. We have taken two different circles. So, angle AOB equal to angle CO'D. So, angles subtend by the chords of a circle at the center are equal, then the chords are equal. So, we need to prove that the chords AB equal to CD. So, the proof is here OA, OB, OC and O''D. O''C and O''D are equal. Why? Because we have taken two congruent circles. Two circles are congruent. Two different circles we have taken. Both of the circles are congruent. They have same radius. The two circles are congruent. They have same radius. So that OA equal to O''C and OB equal to O''D because radii are equal. And it is given that angle AOB equal to angle CO''D. So that angle side of one triangle equal to side angle side of the other triangle. So, by SAS congruency criteria. Triangle AOB is congruent to triangle CO'D. So by CPCT, we can say AB equal to CD. That means the corresponding chords are equal. So angles subtend at the center are equal, so that the corresponding chords are equal. This can be proved in one single circle also. So if we take a circle and take two chords also in the same circle and with the center O, so angles subtend at the center are equal, we can say the chords are equal. So here AOB and COD, here this angle is given, angle is equal, both of the angles subtend at the center are equal is given, and all the radius are equal, so that by SAS congruency both of the triangles are congruent. By CPCT we can say AB equal to CD. Next, perpendicular drawn from the center of the circle to the chord bisect the chord. So perpendicular drawn from the center of the circle to the chord. So given is OL perpendicular to PQ. So that we need to prove PL equal to LQ. This perpendicular will bisect the chord we have to prove. So OL is the perpendicular, so it will make 90 degree here. We'll go for the proof. So if we prove both the triangles are congruent, by CPCT we can say PL equal to LQ. So first we go for the congruency part. In triangle OLP and OLQ. So here OP equal to OQ because they are radius. So the radii are equal. All radii are equal. And OL equal to OL. OL is the common side for both of the triangle. And this OL is making perpendicular to the chord PQ, so that angle OLP equal to angle OLQ. Both of the angle is 90 degree each. So we have right angle, hypotenuse and the one side of one triangle equal to right angle, hypotenuse and the one side of the other triangle. So by RHS congruency criteria, triangle OLP is congruent to triangle OLQ. So by CPCT we can say by corresponding parts of congruent triangles PL equal to LQ, which implies that this OL perpendicular drawn from the center of the circle will bisect the chord. This will bisect the chord has been proved. Next, theorem 10.4. The line drawn through the center of the circle to bisect the chord is perpendicular to the chord. The line drawn through the center of the circle to bisect the chord is perpendicular to the chord. We need to prove it is perpendicular. And it is given that it is bisecting. So, what is given here? AM equal to BM is given. What we need to prove is angle OMA equal to angle OMB equal to 90 degree. We need to prove it will make perpendicular. We'll go for the proof. So if you take both the triangles, if we prove congruency, by CP/CT we can say the corresponding angles are equal. So these two angles are equal. And if both of the angles are equal at the point M, it will make linear pair. The total sum is 180 degree. So that if each angle is 90 degree can be proved. So if it is 90 degree, it is perpendicular to the chord. So in triangle OMA and triangle OMB, in both of these triangles, OA equal to OB because they are radii. Both of the radii are equal, and OM equal to OM, that is the common side, and it is given that AM equal to BM is given. This is given and this is the common side, which implies that OA equal to OB and AM equal to BM, and this OM is the common side. So that all sides of one triangle, each side of one triangle equal to each side of the other triangle. So we are getting SSS congruency. So by SSS congruency criteria, triangle OMA is congruent to triangle OMB. So both of the triangles are congruent. By CP/CT, we can say angle OMA equal to angle OMB. So at a point M, angle OMA plus angle OMB equal to 180 degree. And both of the angle are equal and total sum is 180 degree. 2 times angle OMA is 180 degree. That means angle OMA is 90 degree. So if OMA is 90 degree, OMB also 90 degree. So both of this angle is 90 degree. We can say OM is perpendicular to AB. So the line drawn through the center of the circle to bisect the chord is perpendicular to the chord has been proved.